All right, let's get started. We have not quite a full house, so that's kind of nice. Anybody have any questions before we get started? I found out this desk moves up and down. It's kind of cool. But it's really weird. Like, I don't want the desk up here because I can't see all of you beautiful people. So let's start off right where we left off on Wednesday. So what we've been talking about here is we've been talking about scopes and specifically how to resolve and how to determine what a name is in a program. So what does it semantically mean when we see an identifier or a name? And so we talked about how long, once a name is declared, how long is that name valid for? Is it only valid till the end of that function? Is it valid until the end of that program? Is it valid forever and ever and nobody else could ever use a different name? And so the flip side of this question, so one question is, okay, when I declare a name, how long is that name valid for, right? So that's one side of the equation. The flip side is when I see a name in a program, how do I map that back to its declaration? So how do I resolve? And so this is called a resolution of how to map a name back to a declaration. And scope, so we've kind of talked about scope. I think up till now you've learned a bit about scope. So we've talked about it now, and what we're going to do is we're going to define the different types of scoping and how you can do scoping. So I like to think of it as scope is the semantic behind answering these two questions. So how long is a declaration valid? So when something is declared, a variable is declared, a function is declared, how long is that declaration valid for? Where kind of long is kind of this abstract term. And the flip side is, okay, how do we resolve a name? So if we see a name, how do we know what declaration that maps to? So what does, as far as terms of length goes, how does C do, what's the C scoping rule? Anybody? Yeah.
It's the braces within which it's
The braces to what?
the open and closed braces within which it's declared.
Yeah, so C does what's called block level scoping, right? So whenever you declare something, it's valid in between those braces that it's declared in. And so declarations are valid in that block that they're declared in. What about if a declaration is not in a block? It becomes global. So what does that mean? What does global mean? Does that mean
valid for the entire file that it lives in?
valid for the entire file that it lives in? Is that true?
No,
Is it false?
everything that references it.
So like, yeah.
If it's in the header file of something, that means anything that references that header can access it.
Right. So yeah. So it is valid in that file that it's declared in, right? So that's part of what global is. If it's not declared in a block, it's going to be valid from that declaration till the end of the file. But also, it can be included by other files and other programs can call access that function or that variable. What about if the static operators apply to a global variable? How does that change things? Yeah.
The common instance of that variable is accessible for an object.
I'm talking about in C, so no objects. So global declarations with the static. Yeah.
It's just the file that's declared.
Yeah, so just the file. So that does actually restrict the definition to say only this variable is only accessible in this file, and no other files can include it or call that definition. So this is pretty much what we just said here. So what about JavaScript? Anybody have familiarity with JavaScript? What are the, yeah?
Well, it's like the document object model.
No, I'm talking about scoping, right? So C uses block level scoping. What does JavaScript use?
File. No, it's just through the window. I know that we use namespaces because you can override the variables.
Yes, but how? I guess so. There are global variables in JavaScript, right? Definitely. What about just the standard, like if you declare something, how long? It's like every declaration of a variable is not.
It's global unless it's not functional.
Unless it's in a function. Okay, there we go. So yeah. So JavaScript uses function level scoping actually. And so that's why you have to use crazy tricks like if you want to restrict, so you can't just put braces around something And so you can't have variables specifically in an if statement or an else statement. The variables are declared for that whole function. So you have to do a lot of tricks, and you create these functions just to restrict the access of a variable. So that's a common trick in JavaScript, right? Because otherwise, if you do declare globally, it's accessible. There's no static or anything like that. Anybody can access those variables. And so yeah, declarations are valid in the function that they're declared. So does everybody get the semantic difference between the two here? Yeah, questions about that? Okay, so this is one half of the scoping rules, right? So this does the how long is something valid for, a declaration valid for. Okay, so we're going to look at an example. So here I've got a C program. So remember, we're talking about now C-style scoping. And I've got a main function. And in that main function, so these braces here from this function introduce a new scope. Right? So it's got block level scope. These braces here define a new block. But there's no restriction. I can define more blocks. So I can define another block, and inside that I can have an integer called I. I can set I to be whatever I want, 10,000, and then I can print out I. And then I can define another block outside of this, and I can print out I. So what's going to happen when I compile this program?
Error.
Error? What kind of error? It's a PowerPoint slide. You can't compile PowerPoint slides? Syntax error. Is there a syntax error in this program? It could be. There's not an intended syntax error. Let's put that. Yeah, so which variable is being referenced out of scope? Which I? The second. So the second printf statement, right? So in this block here, I'm referring to. So remember, scoping affects how to map a name to a declaration. So when I see this I, so here we're assigning 10,000 to I know how to look up, and we'll get into how exactly we look up, but I know that, hey, this I refers to this declaration of I, right? So now when I say print out that I, this variable, this name I maps to this declaration of I. But we talked about, right, so C has block level scoping rules. So this I is only valid in the block that it's declared in, and it's not valid outside of that block. So when I try to use this name I, the compiler goes, I don't know what that name refers to. There's nothing that's been declared as the name I. And so it's going to give me this error depending on exactly which compiler you use. Yeah?
Let's say you declare I outside of that block, but not in that first.
We'll get to it. We'll get to it. Don't worry. Yeah, so this is just kind of showing that, hey, there's, so this is just to show that things are local to that block. And so you can't access that same declaration in a block outside of it. Okay, so yeah, this I is valid in this block here. And so those I's all correspond to that same declaration, but this last I doesn't have anything that it resolves to. So that's why the compiler says, hey, I is undeclared. You've never declared that there's a name called I. And what is it? Is it a variable? Is it a function? I don't know what it is. Okay, so let's try and fix it. So now we have our program. We've got our first block. We've got I. We're setting I to be 10,000. We're printing out I. And then we're going to declare I, and then print out I. So will I be able to compile this program? Yes. So I guess another way of asking that question is, will there be an undeclared identifier error when I compile this? No. Why?
Because you declared all variables.
Yeah.
You declared all variables. The second I is, to the extent of my knowledge, isn't going to contain anything, but it's still declared.
All right, we'll get to that in a second. But yes, so it is properly declared, right? So at least the compiler will know, hey, this reference of I corresponds to this declaration of I. So here's maybe a curveball question. Where does the printf come from? Is the printf a name that we need the compiler needs to resolve?
Yes.
Yes? Yeah, so where does it live? Was it? Somebody want?
Probably defined in the header file.
In which header file?
Standard.
Yeah, so standard IO.h, we can assume, actually, so if you go look up the definition, you'll see that the stdio.h includes a definition of, or a declaration of the printf function. And the way headers work in C, all that's essentially happening here is when we do this pound include, we're saying paste whatever's in standard IO.h right here. And so that's why we have access to those declarations. Okay, so I can compile this. If you're very astute, you may have noticed that we removed a warning, the warning errors from our compilation. So what's it going to print out when I compile this program? What's the first thing it's going to print out? 10,000, right? So it's going to go into this block, it's going to print out I, where we know this I refers to this declaration of I, and we know that the I that we set to be 10,000 is also the same declaration. So they both refer to the same variable. So we'll print out 100,000. We'll print out 100,000. So what's the next thing it's going to print out? Oh, is it wrong? That's wrong. That's weird. All right. So what's the next thing it's going to print out?
Whatever value is in the memory address, it's assigned to.
Okay, maybe true. Somebody else said other stuff. What was some other stuff that was said? Is it going to print out? So I guess what's the C standard say it can or should print out? Yeah.
I know some languages it's 0.
Some languages it's 0. So what do you mean in some languages it's 0? That like.
I can't remember if C does it, but I know certain languages like you'll just set it to 0.
Set what to 0? So. Why? Okay, that's what I'm looking for, the default, right? So, so the problem here is we've never initialized this I. So this declaration of I in this second block is a new declaration of I that is completely separate from the I in the first block. So this assignment of 10,000 to I in this first block only affects that variable in the first block. But when we declare a new I in the second block, well, now that has never been assigned to, so it's uninitialized. So on this example, which is I think this first example was the CentOS 6.7. So it just outputs 0 because, like you said, that just happens to be the value that's in that memory address. But the C specification says that any uninitialized, like taking the value of an uninitialized variable, it could be anything. So the implementation is free to do whatever it wants. It could 0 all the values explicitly. It could just print out whatever's there. So running it on my laptop, I can compile it, and it's going to print out something completely different because it's a different compiler, different operating system. So this kind of illustrates hopefully two concepts. So while this program is valid, right, it's syntactically valid, we can compile it. It's also more or less semantically valid because the C compiler, the C standard doesn't say you can't use an uninitialized variable. It just says that the value of that uninitialized variable is unknown. So that's why we get two different values here, but it's still kind of okay. But if you turn on warnings, so this is why in all of the examples and all the homeworks we say turn on all warnings, because the compiler will issue a warning that says, hey, you're using an uninitialized variable. It's probably not what you meant to do. Questions on this example? Yeah.
Yeah, just that number you got, the 166 one. Is that supposed to be like a random variable, or like is that an address? Or just do it
It's whatever. It ends. I think in this implementation, it ends up being whatever is in the memory address that's on the stack right there at that point. So in this case, it happens to be probably a memory address. I didn't really look into it further, but it could be anything. The compiler could just say, I'm going to print out 42, whatever I want. Like I'm going to set that to be that value. It's just as valid as either of these two implementations. Any other questions?
The same as kind of heap memory.
Say that again? Same as heap memory. No. So heap memory is created when you call malloc. Right? Malloc, you're creating some object on the heap.
I'm saying the rules say the same semantics apply to.
So no, because right here we're just talking about the names. So whenever you allocate some object on the heap, right, you have to give it a name, otherwise you can never refer to it again later. So this is only talking about names. You don't have to initialize a heap object. You do, because you just get back a chunk of memory, right? Yes, so what you get back from malloc is a pointer, right? But it's a pointer to some memory that has, so if you try to say what's at that pointer, it's going to be garbage until you assign it. So yeah, I guess you think of the assignment semantics here are the same, but kind of what we're talking about here is resolving that name I. Right? I could be a pointer that's declared, it could be whatever, an integer here. Okay, so when we see a name, right, when we're trying to analyze a program or understand a program, right, when we see a name, we need to map that name to a declaration so that assignments happen to the same declaration, and so that when we print things out, when we access variables, they all refer to the same thing. So to do this, we use a data structure that we're going to call a symbol table. And it's actually incredibly simple. So it's mapping names to declarations and attributes. So what would be some attributes? The name's kind of easy, right? It's the name of whatever thing. But what's an attribute that we might want? Yeah.
Like variables that you have to pass through a function.
So yeah, so if it was a function, right? So a function is just a name. It has a name. It has some declaration where that function was declared. It also has a body where that function was defined, so that the body may be an attribute. The parameters that we pass to that function is an attribute. Maybe not. But yeah, definitely one of them. What else? Yeah. The pieces of data stored in a struct would be the attributes. Yeah, so when we define an attribute, when we define a struct is declared, and then each of the types and names of each of its struct elements, is that right, are declared. So we have to keep track of those. When we see that struct later, we need to know if it's being accessed correctly. What about just a regular old variable? What are some attributes that variables have? Yeah.
Like public, private, static.
Yeah, public, private, static. What else? Const. If it's constant, what else? What's like more basic than all of those things? Yeah.
Variable type.
Yeah, the type. Yeah, the type of the variable, right? We want to be able to map that name back to the declaration where that type of the variable is declared. And so that's basically all a symbol table does. Is it's just a huge table that maps a name to a declaration and an attribute and attributes. Okay, so there's two major types of scoping that we're going to talk about here. These are very important to understand. One is static scoping. So this is one that actually we're probably all most familiar with in our day-to-day programming because the majority of modern languages have some form of static scoping. And so the idea here, like it says in the name, is that the resolution of a name to a declaration is done statically at compile time. And so the way I like to think about this with a symbol table is the compiler creates the symbol table as it's going through the code. And creates the symbol table so it knows how to resolve future names, future references back to the declarations. And so it's doing this all statically at compile time. So what's the opposite of doing something statically? Doing it dynamically, right? Or the other way would be doing it at runtime. So the other way to do this is to do what's called dynamic scoping. And in this case, we actually are resolving names to declarations dynamically at runtime. So this means that just looking at the code, you may not be able to tell exactly what declaration a name references because it could change depending on the runtime behavior of the program. And so the way this is implemented and the way to think about it is, in this way, the symbol table is going to be created dynamically. So the compiler puts code in there to keep track of the symbol table as the program's executing. So when functions are called or new blocks are hit, declarations are added to the symbol table, and then when functions return, declarations are going to leave the symbol table. So we're going to see an example of that. Maybe have high-level questions on these two concepts, or even any questions on these concepts. Yeah?
Would C be static scoping?
Would C be static scoping? Yes. So C is static scoping, so I guess why?
Because it's easier.
Because it's easier. Okay. well, I guess how do you know that it has static scoping? It's maybe a more tricky question than I intend. So one way would be you look at the specification and it tells you exactly what the scoping rules are. Nobody ever does that. So how would you know from your own experience with C or C++ why would it be static scoping? You want to keep going, or you want to pass it on?
You can't turn a string into a name.
You can't turn a string into a name. So that is true, but it's not. It's actually not the difference between static and dynamic scoping. So we're going to get into it. Don't worry. Yeah. Anthony?
The only time I've ever seen dynamic scoping is with objects via classes.
In what sense?
In object-oriented programming, so defining polymorphic pointers. C doesn't have that.
C has a great start.
That's my guess.
Okay. So you can have a language that is object-oriented that has static scoping. So like Java,
Yeah,
object-oriented, static scoping.
Yeah, all of them do, but the object-oriented allows you to do dynamic scoping. That's my
Still no. but that's good. I like where you're thinking. Because there are a lot of things that happen at runtime with objects that kind of muddy the waters. Yeah.
You can't change what a function does at runtime.
You can't change what a function does at runtime.
You can't like substitute one function for another function.
I'm not 100% sure if that's true, because you can pass in pointers to functions. And if you call the pointer to the function, you can pass in different functions. So
That's not actually modifying like the name.
that's true. Okay, so so the big point is here, when you see a name in a C program, right, like a call to a function, you know it only maps to one declaration of that name. Now, if that name is a parameter value, maybe the runtime behavior, the value of those parameters will change, but what that name refers to is not going to change. So you got the kind of high-level way I like to think about it is dynamically scoped. It's almost like everything is global in some sense. So when something's declared, any other function can now access that variable, and any function in the call stack can change that. So we'll see an example in a second. But yeah, so you can look at a piece of C or Java code and say, I know whenever this variable is referenced, I can always map that to a declaration. Right? You can map it to that block that it's declared in, or the header file that it was declared in, whatever. You can always statically map that, and it's never going to change. Okay, so let's look at an example. We're going to look at,
Is Python dynamic scoping?
is Python dynamic scoping? No. So, and this may be one of these really tricky things. So even though Python is dynamically typed, and a variable can have more than one type throughout its lifetime, still, a variable is only ever going to be, it's known statically what that variable refers to. I may have an example in here. Common Lisp, or some Lisp variants, allow you to define variables that are dynamically typed, so it's actually kind of cool. You can decide which ones you want to use for different variables. Other languages, like older versions of Perl, were dynamically typed, but recently now I think that's like an option. So there are some languages that do it, but not a lot. Yeah?
Is this dynamic typing or dynamic scoping?
Scoping. Did I say? So I meant dynamic typing to talk about Python because it gets confusing because it does have dynamic types, but a static scoping. So they're distinct concepts. Okay, so here's our simple C program. We're going to look at it. We're going to walk through it both in normal C with static scoping, and then we're going to walk through it in dynamic scoping to see that the behavior and the execution of the function of the code actually changes. So this will be something that you'll need to do so that way you make sure you understand the differences here. Okay, so here I'm including this header file. Presumably it defines a bunch of stuff. I'm declaring an integer x. So what's the scope of this integer? Global. Yeah, so it's in this file, it's from here to the end of the file, and also any other files that include this object file can call and access this I, or this x. I'm going to declare a function bar. So what am I actually declaring here? Yeah, I guess I can say that. So why don't you restate what I just said? Yeah.
That it's a prototype, basically. You're allowing the compiler, because it's a single pass compiler, to know that anywhere that this function actually exists, so that when you come to it, it's not like, oh, where is this?
Right, so here I'm declaring a function. I'm saying there is a function called bar that takes in no parameters and returns nothing. I'm declaring it, but I'm not actually defining the body of that function. So the compiler, when it's processing this, can actually create an entry in the symbol table for the name bar. So it can still map bar, like the name bar, to this declaration and the attributes, but it just won't know until later where that's actually defined. Okay, so we declare bar, then we're going to define a function called foo, and inside foo, we're going to define a character C. So where is this character C valid in? Within the block foo? Yeah, exactly. Okay, so we're going to set variable C, we're going to call bar, and then we're going to print out x space C, followed by a new line. Then we're going to define a function called baz, and baz has not been called yet, so we can see here that we've called bar within foo, right? Right here, the second line of foo. So, so this is why we need that declaration before defining foo, is we need to have bar defined. Okay, so then we're going to look at the function baz. It's going to print out the variable by the name of x, and then it's going to set x to be 1337. Now here's where we actually define bar, the body of bar, and we say, okay, bar is going to set x to be 100, then it's going to call baz, and then we finally get to our main function. So the main function is going to set x to be 10, and then inside of a new block, we're going to define a character pointer called x, and we're going to set it equal to the constant string testing, or the constant character pointer, character array testing, and then we're going to print out x, and then we're going to call foo. Okay, so questions on this code about anything about what it's doing or does, or who calls what? Yeah.
Shouldn't the main function return something?
Yes, but I was running out of space, so I did not do that. I think I did it in the one that I actually ran and compiled, but yeah. Yeah.
Why are you declaring it testing as a character pointer and you're printing out x rather than a reference to x?
It's because the semantics of the printf format string %s takes in a car star, a pointer. So it dereferences that pointer and prints out whatever's there until it gets to a 0. Any questions? I thought you were going to ask why I just created something and then passed it to something else, and that's for example purposes. Any other questions? With the code? We got it? So what's the order of function calls? So what's the first function that's going to be called? Main, and then foo. Now what's foo going to call? Bar. What's bar going to call? Baz. And then we call back up, go back up, and then we exit. Cool. Okay. So we talked about this. So okay, we're talking statically scoping now. So this declaration of x, int x, because it's global, it's going to be valid from that declaration of x all the way till the end of the program, to the end of this file, and also in other files, but we're only talking about this one, so that's all we need to think about. So where is bar valid from? So this is what I'm illustrating here on the right, is the length, the scope, the time, the amount of code that x is valid for. So what about bar? So we're going to take a crack. Yeah? Good hands. Kind of up. Sorry.
I think it's just one line less than x.
Yeah, one line less. So it starts there at bar. So even though bar is actually defined, the body of bar is defined later, we can refer to bar as a function all the way from when it's declared to the end of the file. Okay, foo? Yeah. And? No? Don't start randomly calling on people? It's always fun. Yeah.
One more line down.
Yeah, one more line down. Okay, foo. All right, so we're not going to do that for any other functions. You can see, so one of the things is to ask yourself, well, why? Why are these defined from where they are to the end of the function. So we talked about with x, right? But why is foo valid there till the end of the file? Yeah.
Because it's at that point, then the block is, I guess, the entire program after that.
So yeah, so in this case, foo is not defined in a block, right? So foo is the name. The name is being declared in the global scope. So that's why it has the same scope as int x. So this is kind of one of the things I want you to kind of try and wrap your head around. There's no difference here. So here we're just talking about names, right? There's no difference between x and foo and bar and baz. It just happens to be that bar and baz, their attributes say that they're functions and they have a certain function signature, which we'll talk about in a second. And x happens to be an integer. But as far as we care when we're compiling it, we need to be able to figure that out later on when we see this bar. Because what if we had put x brackets, right? Tried to call x. What would that be?
Syntax.
Is it actually a syntax error though? Is it not syntactically valid?
Semantic.
It's not semantically valid, right? Exactly, because we can't call an integer. Yeah, we can call a function, or we can call names. So syntactically, that's all we care about is we have name, parentheses, maybe something that's separated by commas and then an end parentheses. But that's all we care about. But semantically, when we want to say, is this a valid call, we need to map that name to the declaration and see, is that declaration a function or is it an integer? Okay, so we talked about C is defined in this block, right? So its scoping is just those 3 lines of foo. What about the integer x in bar? How far? Yeah.
Just within that block.
Yeah, just within that block, right? So it's just defined in that block. And the other thing to note here, right, is that it doesn't matter that there's already an x defined globally, right? So we'll get into the specifics there. Okay, and then the other, in this last block here, there is a character pointer called x. Okay, so let me see where we're at. Okay, so the question is, so now what we're going to do is we want to resolve all these names to their declarations, right? And so we're the compiler. You can think about it, we're kind of just going through the program from the top to the bottom, looking for all the names and trying to map them to declarations. So wherever we see a declaration, we're going to create an entry in our symbol table with all the attributes. And wherever we see a name, we want to try and map that back. So what happens if when we see this bar name, what do we map that to? What was it? Yeah, so we map it, well, let's go to the scoping rule. So we're going to map it to that bar. So we know that that bar is referring to that bar that we declared a couple lines above. Okay, what about the x in this printf? The global x, right? So it's going to be here, right? It's not going to, and that's because x was declared globally, and we can look statically here, and we look outside the scopes, and we say, okay, is there an x declared in your block? No. Is there an x declared in the global scope? Yes, there is an integer x, so that means that this refers to the name x. What about the C? Yeah, the one within foo. So by the same logic, right? We're going to look at this C and say, okay, is there anything in my block, in this encompassing block? Yes, there is a variable called C, and its type is character. Okay, and then we go through and then we say, okay, printf, where was printf defined? Yeah, standard io.h, we talked about that, that's good. And then we just keep going. So then we look at this x and say, okay, where does this x map to? The global x, right? Exactly. So this x, when we see this name, we know it's the same declaration as that x on line 2. Okay, now going on, what about this x? Same thing, global x, right? Or is it this one? Why not? It's not in the same block, right? It's not in the same scope. So this integer x is only defined in the scope of the function bar. So the X in main can't access that. It can only access the global X, which is, okay, and then also, so can it dip into this other scope to talk to this X? No, it also can't. So it's got to actually, and statically, remember we're doing this statically, so we know that this X maps to that integer X. Okay, and then when we see this X though, now we say, well, are there any X's, anything by the name X in its surrounding block? We say, yeah, there's actually a character pointer called X here. And so we can use that. So this is where, so I don't think we're going to call it out specifically, but so we've probably learned about shadowing of variables in scopes. Yes? No? No? Okay, so in this block here, right, this X, can this X ever refer to that global integer X? Not in C, good answer. Yeah, so no, we're using C. We can't ever get to that global that global integer X, because every time we use the name X in this block, right, we're going to refer to that character pointer that's defined at the beginning of the block. So this is called shadowing. In effect, we've shadowed the global X. We can never reach it. Okay. So what's going to happen when I compile this? Is it going to give me any errors? Yeah. Say that again?
If there had been percentage D instead of percentage S
Ah.
in printf, it would give an error.
If it would give an error is a tricky question. So like a compile time error, maybe depending on how smart your compiler is, if it can read this string here. But yes, if you try to do that at runtime, instead of printing out the string testing, you print out, I think, the pointer to that string. So you'd be printing out whatever's in the value X there. Yeah.
In the foo method, you are
Yes.
saying the scope is from the fourth line to the end, right? But sometimes,
here?
like, yeah, this one is. But sometimes we call that method before the declaration, and even then compiler doesn't give that.
So call which function? Say that again.
So let's say I'm using the foo before the fourth line in my function, then it won't give me the error, right?
No, it will. So you can't. In C is very strict. You have to define. You have to declare foo before you use it. So this is why, like, if we try to remove this void bar here, even though we're defining bar later down, C will complain and say, hey, I don't know, you're making this call to bar. I've never seen bar. It's an uninitialized, like it's undeclared.
But that's not the case in the Java actually, because we can call the methods before and then declare it afterwards.
So this is why scoping rules get very complicated depending on language. So yeah, in Java, the scope of well, in this case, you don't ever really have, you very rarely have global functions. I don't even know if you can have that in Java, right? So you have the classes, and then you have functions that are inside of each class, and there the scope actually extends both ways. So it extends, so all you have to do is define a function, then you can declare it or call it from any other function there. So yes, and you could think about doing that in C. You could do that, right? You just have to you make one pass looking for all of the global functions, right? Global functions and global variables, and then you go back and recompile. But they chose not to do that in their language. Okay, cool. Good question. All right, so what happens when I compile this? Is there going to be an error? Okay.
The X in BAS hasn't been initialized yet.
The X in BAS, this one?
Yes, it hasn't been initialized yet.
How do you know?
Since it's called in bar.
Right? But where's bar called? So that's a good question, right? So if you just look at this from top to bottom, right, we don't really know if X is going to be initialized before we get to bar. But that's actually why checking for use of uninitialized variables is very difficult, especially in this case where it's a global variable, right? So you got to think anything could happen before we get to BAS, right? And one of those things that could have happened is somebody could assign a value to X before it gets to us. So it could be some of the time there's an uninitialized variable. There could be some program pass where nobody initializes it, and there could be some program pass where it's always initialized. So it's easier for the compiler to tell when it's a local variable because it knows only these instructions are going to be executed. So I can make a statement that I know the exact order these things happen in. Whereas in this case, I don't really know the entire order of everything that's going to be called before we get to Baz. So are there going to be any other errors in our compilation? Sure. It will complain about the lack of a return value on main, but say we fix that. Okay, so it compiles, yeah.
Can you repeat the part on the shadowing with X?
Sure. So the basic idea is here in this X. So when we get to this block, right, this name X inside this block will always map to this character pointer X, this declaration. Even though globally there is an integer X declared, but the way the scoping resolution works, we go inside out. So we always look in our local scope, and then if we can't find it there, we look in our enclosing scope and the enclosing scope until we find that name, or if we don't find it, we call it an error. Yeah?
In bar, isn't that shadowing as well because you make a local in X?
In bar? Yes, in bar it's also shadowing, except that we don't actually reference that X.
Yeah.
So, but yeah. But yes, X is also shadowed
Call
here.
the global variable from bar.
Exactly. Yes. Cool. Any other questions? Okay, what happens when we run it? So what's the first thing it's going to print out? Yeah. Okay. Question.
If you put it in bar instead of put index equals 100, what would happen if you put index equals X?
Oh, okay, so I do know. So if you put int x equals x, so in this case, actually that's a very good question. I'm not 100% certain. I think in general it's an error and the compiler should complain if you try to use the same name in an assignment of a declaration. So I think it would, I think in this case it would look at the x first and then say you're trying to assign x to x and it shouldn't work, but that's a good question. You get a warning. I guess the question is it going to work if you have a global variable also called the x? Like, is it going to use that one? I don't think it would use that one. But yeah, that'd be good. Somebody should, well, do that later and definitely not during class. But if you did, you should tell us. Okay. So we execute this program. What's the first thing it's going to output? Testing from which function? Main. So we hit this printf, right? We start in main. So when we print out testing, so the value in our local scope of x is testing, but what's the global value of x? 10. Yeah. So then we call foo, and then what's the next? So then we call foo, and then we set a character star is equal to c. We call bar. We go down here. We set this local x to be 100. We call baz, and then we print out x. So what's this x going to print out? 10. Right, so statically we know this x is this global x, and we set that earlier in the main function to be 10 on this line. So this is so we'll see testing, we'll see 10, and then this is gonna set x to 1337. So which x is this referring to again? The global one, right? So the global x is gonna have 1337. Baz is gonna return, bar is gonna return, and then we're gonna print out x and c. So what's this going to print out? 1337 space c. Okay. And then foo will return, and then main will return, and everything will be awesome. And so you can see that, well, we knew exactly which name was being assigned to in each of these functions, right? Statically. We can look at this, and we can say, oh, this x is always referring to here, and this x in baz is always referring to this global x. So that x in baz is never going to change and somehow point to this x in bar. So questions about static scoping? This should be kind of the easy-ish one because this is what you do all the time when you're coding. So then we look at the flip side, so dynamic scoping. So as we said, the symbol table is going to be created and updated at runtime as the program is executed. So that when we want to resolve some name, let's say X, we have to look it up in the symbol table for the last encounter of that declaration with the name X. And that's what we're going to refer to. So because of this, X could change depending on how a function is called. So here, you think each function or each block in the call stack is going to add its own declarations to the symbol table at runtime. Therefore, if you have a function that references what would normally be a global variable X, it could actually reference a variable X in a different block depending on how it's called. So yeah, common list allows both, is what I said. And so this is kind of what makes it a little bit crazy, why it didn't really catch on. Okay. So remember, this is all happening dynamically. So we're going to think about, we're executing this function. We're going to kind of just pass through it first, getting all of the, you can think about maybe if we're an interpreter, right? We're going to start at the beginning. We're going to look at all of the global declarations until we get to the main, and I'm going to start executing main. So what I'm going to do is this time I'm going to show the symbol table as we go. So when I hit this declaration X, so let's see. Okay, yeah. So I'm going to create in my symbol table, I'm going to create an entry for the name X. I'm going to say it has the attribute of integer, and on the right-hand side, I'm going to show the value. But currently it has no value, right? We haven't assigned anything to it. So then I go to bar, and I'm going to create a name called bar in my symbol table here in the global scope. And I'm going to say, okay, bar, let's say, so here we're going to get to it next or next. But you can think of the parameters, so yeah, inside the brackets is the parameters that we're passing into bar. And in this case, well, there's nothing. There's no parameters to bar, so we're going to represent that as void. Okay, so then we're going to go to foo, and we're going to say, okay, we've declared a foo, and we've seen a function called foo, and we know it has also, its name is foo, it's a function, it has the parameters, it has no parameters, but we're also going to say here that it's also defined on line 4. So why don't we have a line definition for bar? Yeah, we don't have the definition yet. We don't know, we've just seen the declaration, right? We have nothing, so we put nothing right now. Okay, so we call foo, we see foo, we do the same thing with baz. We say baz is on line 9. And then when we get to bar, now here we can go to our symbol table, look up and say, okay, do we have anything named bar? Yes, we do actually, and something without, that doesn't have the definition. So we can go there, update in our symbol table that actually bar lives on, let's say, line 13. And then we keep going, and then we go to main, and we're going to say, okay, now we actually have a function. We see a function main. Its type is also void, and it lives on line 17. So let's say we went through the global scope of our programs once. So we create this symbol table. So this is the global scope of our dynamic symbol table. So now we're actually going to start executing main. So when we hit this X, what does this X resolve to? Global X. So this X. So all we do, remember, is look in our dynamic symbol table, which is full of the global scope right now. And we say, okay, look up, is there an X? Yeah, there's an X. Great. We're going to set its value equal to 10. And then we'll be good. So then we're going to go into this block. Now, excuse me. Now remember, scope here is going to be updated dynamically. So when we get to a new block, we're going to actually create a new scope here. And so I'm going to kind of represent that with like an arrow in our table. And when we see this character X, we're now going to create a new entry in our symbol table called with the name of X. And what's the type of X going to be? Char pointer, yeah. character pointer, and it's going to have the value testing. So we're going to create that in our symbol table dynamically. Then we get to this printf, so what does this x refer to? Testing, right? Yeah. So this x is going to refer, so we're looking in our table, right, from our closest scope out for the first occurrence of the name x. So in this case, right, there's a name x in our closest scope, and so we're going to say, okay, this x has the value testing, so I know which one that is. So I'm going to be able to print that out. Okay. Then what happens when I leave this scope? Goes away. Yeah, exactly. So this, we're going to completely get rid of this scope because we know we've executed that block. We'll never be able to access those names anymore, so they go away. Okay, questions so far? So has there been any difference? Yes? No? Not yet. A little foreshadowing of an answer. Okay, so now we call the function foo. So we look up, we see a name foo. We can actually look that up in the symbol table and say, oh, foo's on line 4. Go start executing at line 4. So we jump into line 4. And now, once again, so have we created a new scope? Yes. So which scope is this? The foo scope. Yeah. So yeah, the scope of the block foo, right? So we're going to create a new scope here. We're going to say, okay, there's a character C defined here in this new scope that has the value of C. And so then we're going to execute bar. And when we go into bar, what are we going to do? Scope, yeah, create a new scope. So we're going to create a new scope again, right? Because we're now in the scope of bar. And we're going to say, okay, we're creating, what variable name are we declaring here? X, which is an integer, which we're setting the value 100, right? So here we're creating, in our symbol table, name X, attribute int, value 100. So then we're going to go into Baz, or finally call Baz. And we get into Baz, we would create a new scope normally, but we can kind of see here there's no declaration, so it doesn't really matter. It's going to be an empty scope. Now when we see this X, what is this X referring to? Yeah. You be a little bit more specific. That's probably correct. The X on the screen. The X that's at what? Say again? That's at 100. So why?
Because it's the closest.
Right. So we see the X. We look it up in our symbol table, and remember this bottommost layer of the symbol table is closest to our block. So we're going to look up starting from there and looking in each scope. So we look and we see, oh yeah, I see an X, and its value is 100. So I'm going to print out there, I'm going to refer to 100 there. And I'm going to print out 100. So that X is going to refer to this 100 in this table. So is there a difference here?
But the X that is 100 is only valid in the scope of the...
So this is dynamic scoping. So this is what makes it crazy. So if a function defines a new, so that block is valid not just syntactically for these two lines, but that's valid for any other function calls after that, inside that function. So anything that function calls can refer to variables that are in the enclosing block. And it's kind of, so anyway, maybe I'll talk about it at the end, but this is actually a simpler way to program an interpreter, and that's why a lot of earlier languages would do this, because it's actually easier to code than doing this all statically. Because you can just do this at runtime, and as the interpreter, you can just build this exact table so you know exactly what the values of everything are. Yeah, so this is going to print out 100. And then we get to, so it's not referring, like we did statically, to this global X, right? Because the global X is actually shadowed by that declaration of X in bar, right? So this just happens to be dynamic, this shadowing is happening. But now we can't actually refer to that global X. Okay, then we go to the next one. So same thing. So what are we gonna set? Which x does this name refer to? I guess what value does the x have that this is referring to?
100.
100, right? So we're gonna look it up in the table. We're gonna see, oh, okay, this x is over here. So I'm gonna set this value of 100 to 1,337. And then I'm gonna start executing. Okay, so when I get to the end of this function baz, normally I would clean up its scope, but nothing was defined in baz. So I'm going to return into bar. And then at the end of bar, I'm going to clean up the scope. So this is just like when we left the scope outside of main, right? So here, when I clean up the scope of bar, what am I getting rid of? The x with what? Somebody said? Yeah,
The x with b.
Yeah, the x with 1337, right? So, so I'm going to clean. So this is now out of this block. So I'm going to, you can think of it kind of like a stack, right? Or yeah, I'm going to pop this off. And now when we return, I get rid of that. And now, so I return from this bar function. Now I'm at the printf function. So now what does c refer to? C, the value C, right? So C, when we see this reference to C, we're going to look it up in the table. We're going to say, oh, it's in this local scope, so this C refers to this, has this value of C. Okay, now what about X? Yeah, X 100, so it's going to map to this definition of X here. And then foo is going to return, so we're going to clean up and get rid of this character C in our symbol table. So we're going to return, and foo is going to return, we clean up, or sorry, main is going to return, we clean up anything in main, and now we're done. So, okay, so assuming, oh, I called it static scoping.c. Anyways, assuming we had some crazy dynamic scoping GCC compiler that actually did this.
So that's not real command.
No, I don't think so. That would be a good project, maybe. Just kidding. Yeah, so no, this is not a real command. I guess I should have called it like imaginary CC or something. But anyways, the point is we could compile this with a fake compiler, and because it's a fake compiler, I can say there's no errors. Then when I run this program, what would this fake program output? So what would be the first thing? Testing. Yeah, and then what's the next thing? 10? 100, yeah. And then what about the last thing?
1,337. No, you're right.
10C? The 1337C? 10C. So why isn't it 1337?
Because it goes after.
Right. So oh yeah.
Because once we leave BAS, once we leave bar,
Yes.
we're now referring to the global in X and not the one within the scope of bar.
Exactly. So even though BAS set 133 X to be 1337, and statically this X refers to the global X, but because dynamically bar defined a new variable X before it called BAS, now that X in bar got changed to 1337. But then when it returned, it went away. We don't care about it anymore. So when we got to the printf here in foo, which is the last thing that's going to be printed out, this X is going to refer to the global X, which was 10, which main set. So yeah, it should be 10C. It's a lot easier than a real compiler. Yeah.
Is there a practical use to shadowing, or is it just something you should probably avoid by having multiple types of multiple variables?
Is there a practical use to shadowing? Possibly. I mean, you think of enough use cases, right? There's going to be practical use for anything. Generally, I don't know. It can be nice. Well, it depends on your language. If the language can be really terrible and it's really easy to create global variables, there's a good chance that the name you want, like size, right? You want it to refer to your size and your function, not some function size that's defined in some library or something like that. So it is nice when you know that it's happening, or in those kind of cases. But yeah, generally, it can kind of be like, hey, this is probably a mistake, right? Like you maybe don't want to do that. Some languages actually, like Python, I believe, you have to use a keyword global to say that, hey, this local variable in this scope, I actually want to refer to the local version of this variable and not to create a new variable that shadows the old value. Yeah.
Most languages allow shadowing, but I've seen like characters trying to declare the same thing.
It depends on the language, maybe. So for something like C, so for C, you can't define a function inside of another function, right? So like, I don't know if this is 100% true, but I'd say all the functions in C have to be globally scoped. So is that, huh?
I think every function in C is a unique name.
Right, exactly. So yeah, so that would be in the case where you couldn't, like if you tried to declare a foo here, it would throw an error, even though you could think about maybe it should shadow it for the rest of the file, but yeah, it depends. It's one of those things that depends on the semantics of the language. Like what happens if the name already exists in an existing scope. I think with C++, you can use the scope, the two colons to disambiguate if there's a problem. Yeah. Other questions? So this is something you should be familiar with, so dynamic scoping. So if I give you some code like this and say, what does it output with static scoping, what does it output with dynamic scoping, you'd be able to definitely do that. All right. Okay, so one of the things we talked about is function resolution, right? So we talked about, okay, resolving a name to a specific declaration, but how do we resolve a function call to the appropriate function, right? We need some way to map that. And once again, this gets back to the idea of semantics. And the answer is really, it depends depending on the language. So what are some ways we could use to disambiguate between functions? Yeah, what's the big thing?
Having different parameters.
What's more general than that? Different name, right? Yeah, you just say like, oh, there's foo1 and foo2 and foo3 and foo10, foo100 or whatever, right? Yeah, you just create new names, so that would be one way. So parameters would be another way. What else besides parameters? What else could you use? Yeah.
Return types.
Yeah, you could use the return type, right? So you could use maybe the combination of name and return type need to be unique. So we talked about, well, you could do, so parameters are also kind of, you can have different granularities, right? So you could say, hey, let's do names and the number of parameters, right? So you can define a function foo, and you can define a function foo with 2 parameters, but you can never define another function foo with 2 parameters. So any function foo that's called with 2 parameters maps directly to that function. This can get into problems. Maybe we want to do names plus parameter number plus parameter types. So actually, the types of the parameters. So I could define a function foo that takes in strings or that takes in integers, right? The compiler can hopefully figure out which one's which. Anything else? Is there anything super weird? Hand? Namespaces, yeah, that's a good, something I didn't think about. So yeah, you could give the programmer a way to specify a new scope, right? That's kind of better than just blocks. So you could say, hey, everything in here is in the project or the namespace, I don't know, utils or something. And then later on, you could refer to those functions as util dot something or util colon something, or however you have a way to specify the namespace. So yeah, that's a good one. Anything else? Parameter order. So yeah, okay, yeah, that's good. I'm going to go ahead and say the types here are in an order, right, from 0 to whatever. Actually, one thing I didn't specify here, but it just kind of came to mind, is what about like maybe the names of the parameters? So maybe you could think about having different functions that have the same number of parameters, the same types, but they have different names of parameters, and so that could help disambiguate. I don't know. I mean, we're making up languages here.
If the parameter type is ordered, then the parameter number is unnecessary.
Correct. I just kind of made it explicit here. But yeah, you think about like functions. Some languages you can call functions by specifying, like when you're calling a function, you can specify the keyword, or you can specify which parameter, so you don't actually have to be positional. So maybe there's something there. I don't know. So these are kind of so these disambiguation rules, right? So these ways of distinguishing between different definitions of the same name function, they're often referred to as, I like to think of them as the function signature, right? So what's nice, I don't know if that's true. What's nice about a signature?
Should be unique identifier.
Yeah, so it should be some kind of unique, it should be unique, right? So it should be a way to, when you're defining it, to know, hey, has the function with this signature already been declared or defined? If so, then there's an error. And you could say, well, when I see a function called, I know which function to go to. So can I tell just from the function call, can I tell what function signature was meant to be called here? And these vary completely by programming language. So what does C use as the function signatures? Was it? Somebody want to guess? You can guess, it's okay. I had to look it up too. Yeah. Like
Name.
Name. So yeah, something that actually very surprised me. Yeah, in C, it's only the name. So you can't create a function foo that has 2 parameters and a function foo that only takes 1 parameter. So the compiler will complain because the names have to be unique. So yeah, so I like to kind of think of it as a vector. So this is when we kind of get into more formally like defining it. So I can think about, okay, so the function signature would just be a vector containing the name. Okay, in C++, what's the function signature in C++?
Names plus parameter types.
You want what?
Names plus parameter types plus return type.
So names plus parameter types, does it have the return type? Can you define a function with the same name, same parameters with different return types? No. Why? Somebody want to guess? Somebody want to have a think? Yeah.
Implicit casting.
So implicit casting, you want to expand a little bit?
If you have a function that returns an integer and another function with the exact same parameters that returns a double, you don't know what to use in a given situation.
Right, so the point is that we want to resolve it when we see it being used, right? So you could, if you were, so because of the implicit conversions, right? So I may take, I could not use, what if I don't use the return value of the function foo, right? So I don't even have to use it. So then I could call a function foo, pass it 2 arguments, do nothing with the return call, and then the compiler would have no way of knowing which function I meant with the return type. So you could think about it, you could do it in languages, but in C++, and I want to say Java as well, it's mostly the same way. So they pretty much take the signature is the name and the type of parameter 1, the type of parameter 2, type of parameter 3 for, however many parameters there are. Okay, so this leads us to handy situations where we want to do function resolution. So now we're going to look at a C++ example that's also mostly C. Mainly because I tried this in C and it's like, oh, this doesn't work. That's interesting. I could put that in the lecture. So we're going to define a function foo that returns an integer and takes in 0 parameters, and it's going to return 10. Okay, and so pretty simple function, right? So we're going to define another function foo that takes in an integer, and it's going to return 10 plus whatever we pass in. So in my function main, oh, that's weird. So if I'm going to call foo, so which foo does this match to? The first one. How do you know it's the first one?
No parameters.
No parameters. No parameters in the call, right? So remember, the important thing here is that we're looking at this call and saying, can I go back from this call to that name? And so the question is, well, can I generate a function signature off of this call? Well, yes, I can look at this. I can see, I know the name of this function is supposed to be foo, and then it has 0 parameters. So that's my function signature. And so I can look up, hey, yeah, there's a function foo defined with 0 parameters. Perfect, that matches, great. Then later on when I call bar, right, so when I call, see this foo, so now which foo does this correspond to? Second one, the first one? Second one? Why?
What is text?
defined here, right? So I hope so. So which foo? The second one, why? You want to say it louder?
Because it takes in a parameter.
Right, because so just by looking at this, right, without even thinking about the types for a second, but I can look at this second function called foo, and I can see, okay, the name is foo, and they're passing in one argument, right, one parameter. So that's enough in this case to disambiguate, but I also know the types of the variables, and I can see, oh, the type of this variable test is an integer, so I know that it's the name of foo, and its first parameter is int, and I can look and see, aha, yes, there's a declaration of foo where it has one parameter whose type is an int. So I know that this foo maps to that function called foo. So when I run it, do I have the thing here? Yeah, okay. So when I run it, what is this going to output? So is it going to compile?
Yes.
Yeah? Is there going to be any errors? No? What's it going to output? Somebody want to say that louder than mumble? Yeah.
10 space 20.
10 space 20. So test is going to have the value 10, and bar is going to have the value 20. Is that correct? Does everyone agree? Maybe disagree? All right, yeah, 10 and 20. Perfect. Cool. Okay, so we'll talk very quickly about assignment semantics before we go. To give a little preview of where we're headed. So we talked about scoping, so how to map a name to the declaration, the place where it's declared. We talked about how to define a name's function call to the function where it was defined, or to the exact function. And we talked about function signatures. Now we're going to talk about what exactly assignment means. So we're going to talk about what are the exact semantics behind this statement of not minus x equals y, but x equals y. All right, I'll let you out like 2 minutes early. So when we get back on Wednesday, we're going to talk about this, and we're going to go into assignment semantics and pointers, and it's going to be awesome.